Thank you. And thank you guys
Thank
all
you.
so much for having us. We're thrilled to be here and speak with all of you guys about current tech and happiness and biology and how it all intersects.
Yeah, and this is the book Decoding the World that Arvind, I think.
Yeah.
I will tell you, because many people know my books, this is my 8th book. It's Arvind's first, but this is by far the best book ever wrote, and by far the most fun I've ever had writing a book. We're going to go about 25 minutes. We brought in an agenda. We're going to run it like a book club. And I'm just going to give you the agenda, and we'll see if we manage to cover it. But I think we want to talk, number one, about variant perception. What we mean by variant perception, why it's so important, and why we're going to tell you stuff that we hope other people don't tell you. 2 is that we think of this much more, less 2001 and much more Fight Club. By that, we mean that the thinking part of the brain is less the actual target than the parts of the brain that control our organs and our parasympathetic systems, as towards improving moods and happiness. 3, while we think it's amazingly cool technology and we think it will be applied in the right direction, we think that the way that the brain-machine interfaces are publicly conceived of is actually off base, and we'll explain why. We want to get into some stuff about longevity, and I want to focus very much on a gene called REST and why REST gene is so important. It's kind of defines the identity crisis of our cells. When it comes to longevity, we want to say stop over-indexing on mouse models and stop talking about mouse studies. And we also think that the brain is far more important to longevity than all the rest of the body. And we need to be seeing more studies there. And I want to ask people to think of the difference in life between, if you could ever get there, having a pill that works fast that you could really notice it was working versus a pill that works really slow and you can't even notice it's working, and which one would you rather take? That's our agenda. So let's start at the top. Arvind, you taught me this language of variant perception. I was your student. You were my master. Tell people why variant perception matters to us so much.
So I think variant perception is in the end the true advantage that any individual on the planet has to everyone else, in a sense. And all variant perception is the way you see the world that is unique to you and maybe not shared with the rest of the world. And so it could be, when Poe and I talk about it, we talk about it through biotechnology. And we say, okay, well, what's our variant perception here? Why do we believe this technology is going to succeed where others either don't, or where it will actually have an outsized effect in the long term? And so IndieBio was a product of variant perception. It was very simple. I believed scientists could become entrepreneurs. Most people didn't. And so therefore, there was all of these super talented people that didn't have access to funding. That was a variant perception. And if you didn't have that variant perception, then that opportunity wouldn't exist. The thing about variant perception is it's invisible until you act on it, and then everyone can see it, and then it goes away. And so variant perception needs to be continually updated. And the only way I know to create variant perception, truly variant perception, is to live an interesting life.
Okay, but as it relates to today's talk, our talk.
Yes.
Let's be clear. Where I am at IndieBio that Arvind created, we do have made billions, but we start with the smallest check in the venture business. And so we cannot compete on where there is consensus. People like Arvind, now he's in Mayfield, he has all the money in the world, but he still has a check size. But if everybody believes this, if we tried to do that, we would have the worst company in the world. Because the kind of company we could get for our check size would not get us something special. We have to, at IndieBio, and Arvind taught us this, we have to have an edge, a different perception than others to find things that we think others are biased against or overlooked. And so the stuff we're going to talk about today, we think fits that class. We think these are things that that contradict, and it's totally fine for everybody in the audience to disagree with us. That's okay. Like, we're not trying to give you a consensus opinion. We're trying to give you our perception, and as it guides us as we look at this space.
And I think that's important. If everyone agrees with you, by definition, it's not a variant perception. You need most people to say, I'm not sure about that. That seems a little weird. Like, everything I've been taught tells me that's not true. And that's there's the kernel of it, right? It's your experience that tells you that something might be different than what is necessarily taught. And I think like that's what people call trusting your gut. But that's why, I started talking about variant perception by everyone has it. By definition, you live a life and your experiences tell you certain things. And it's up to you to believe in them and then act on them. And I think a lot of people are afraid, and myself included. I'm not different there, right? It's natural to have fear about acting on something that very few people believe. Like, everyone told me I was committing career suicide starting in bio.
So one of the variant perceptions we have, and there's a chapter in the book about it, starts with a day where Arvind couldn't remember what he had for dinner last night. And he texted his wife, Carissa, and she said it was Chinese food.
Yes.
And he had no memory of eating Chinese food the night before. And he couldn't think of where they ate Chinese food. And as it happened, Sam Rodriguez from MIT was in Ed Boyd's lab, was there at Indie Bio that day. And so we went in a room and sat down with Sam, and we began to understand a new dimension of the brain that we really hadn't heard around before. Because what we were in search of was, where did Arvind eat Chinese food? I.e., the real question was, what is a memory and where do we store it? And what we slowly unwound was a new revelation where we have a paradigm where we think of the brain as electrical and chemical. And that in its regular daily workings, and that there was a new dimension to it that everybody needs to factor into, which is genetic. And I don't mean what are your genes, like I got ApoE4 and so I'm going to get Alzheimer's. I mean that literally Arvind's Chinese food was encoded in a packet of a small RNA somewhere in his brain, and we needed to find it. And that we learned that through activity-related genes in the brain, that when you have encoding memories, you are essentially flying off these small packets of RNA that are moving down to the ends of your neurons and crossing synapses. And that what it fundamentally meant was that if you are just using electricity or light or chemistry to stimulate the brain, you were missing the level, which was to read the information packets that is in that genetic code. That those information packets were, you might think of them as like the musical score for a piano, and that your brain is like bringing up a musical score on a piano. You can play the song. Your brain can replay a memory in much the same way by tapping into that small genetic packet. And what this meant and why we sort of challenge sort of the brain machine interface space is that it's not, at least the public conception of it, because many people are doing amazing work here, is that we and this is why we say it's less 2001 and more Fight Club, that the treating the brain as a conduit of electricity was missing this genetic aspect on a live basis. And what we learned from Sam in the end was that, well, in the end, it wasn't Chinese food after all. It was actually Indian food, and that's why Arvind couldn't remember it. And his wife had just misremembered. However, even then, that memories are actually little buds, and that your inflammation parts of your brain, the glia cells, come along and eat them on a live basis. They come along and they clear up your memories, and they're in a physical form, and they're constantly being sort of grown and eaten and grown and eaten in your brain. And this led us to focus much more ultimately on, let's talk about Fight Club, the medulla oblongata, and the vagus nerve. Arvind, take it from there, maybe.
Yeah.
I've talked enough.
So yeah, no, I mean, I think you nailed it. Like for this conference, the vagus nerve is like one of the grails, right? Like,
Yeah.
I think really understanding this nerve, which is actually not a single like little nerve that's in your head. It actually connects to all the organs in your body through the gut-brain axis, and it is a master regulator of so many systems. And so being able to control it, stimulate it through either breathing, direct electrical stimulation, or other chemical stimulate, other ways that
Optogenetic or laser light.
Yes, more biotech, more cutting edge, but on the horizon is going to be able to start to regulate the autonomous nervous system. The nervous system we can't access consciously, but we are learning to regulate through our actions, and most importantly, through breathing. And this is something that I started to learn actually, and I actually did a session with Wim Hof. We talk about this in the book, in the chapter about breath, where as a scientist, I think it was remarkable to me after doing Wim Hof with Wim Hof himself in a very small session to a few people in Venice, how little I actually knew about the biochemistry of breathing and how all the different all the different areas of our body, areas in our brain interact in order to either stimulate the immune system or stimulate the rest and digest is the phrase system. And we can access those consciously by breathing or by using neural stimulators in order to get some particular outcomes that we normally are getting through chemistry, through eating ibuprofen, right? Or taking antibodies for rheumatoid arthritis. And so here we can start using, I actually think there's so much more we can do about breathing and sleeping, by the way. I think, James Nestor wrote Breath. I think the next big book is going to be Sleep. It's going to be called Sleep, and exploring all the ways that activity contributes to the glial cells that Poe was talking about, clearing up our brain and eventually staving off dementia. And dementia,
let's just connect it to dementia and mental health, because what we're talking about really in the end game here is controlling inflammation. There's a great study out of Feinstein Institute, just came out yesterday or 2 days ago, on how stimulating the brainstem right above the top of the vagus controls inflammation and cytokines throughout your body. You can do this as well through breath techniques. You do it through being punched in the face, but like a lot of things here that work. But what fundamentally our point of view is that mental health will be benefited by treating the brain as an organ and making that organ healthier, and then fewer people will be hurt by the long-term effects of sort of inflammation at the periphery and in the brain. And by having healthy brains, we have better mental health.
That's right. And in the end, more people in the recent study, AARP, more people are worried about cognitive decline than losing Medicare.
So let's talk about cognitive decline. Great lead in. I didn't know that. That's cool. So, because it's the one thing I'm worried about, and because I'm really old. And okay, but okay, let's just sort of say, I think there's a gene that people don't talk about, they ought to be talking about. It's called RE silencing transcription factor 1, goes by the nickname REST. So, and I think it's really important here for sort of lack of cognitive decline. Almost everybody, or virtually everybody, who is 95 years old and has their wits about them. You all have known someone, a parent, a family member who's seen cognitive decline. You've all known someone who seems to have their wits about them at the age of 95, which is amazing. Almost all of them have a very active REST gene. And people who tend to get Alzheimer's and other diseases and die early tend to have a less active rest gene. So this isn't a 23andMe test. It's not like ApoE4. It's not like you have it or you don't having a variant. It's really about the level of activity of the gene. And let's describe what it does. So we all know that in every cell of our body, our entire genome is there. So in your kneecap and in your toenail, your kneecap needs to know, I'm a kneecap, express the genes that make me a kneecap. And in your toenail, they express the genes that make you a toenail. And in your brain, for your cortical neurons, the 16 billion cortical neurons that you have, you need your brain to silence all the kneecap signaling and silence, put to rest all of the toenail signaling, and just express the genes for being a neuron. A very active rest gene, to sort of think of it as an identity crisis, that for people who are having cognitive decline and other brain disorders, one of the things that's fundamentally actually happening is this identity crisis of the cell that is partly trying to, your brain cells trying to be a kneecap or a toenail rather than being a cortical neuron. Cortical neurons are magic. They can last at least, we don't know how long they could last, because in our bodies, they'll last, if they're going well, they'll last 80, 90, 100 years at least, and may go longer. And they never divide. They're very unique as cells. They don't split like all these other cells. You're born with them and they live all that period of time. I think that we should be exploring this space much more to try to understand this sort of larger dimensions of what makes a brain and what makes other cells other cells.
Yeah, and I think the other thing that longevity, there's a lot of activity, there's a lot of excitement about the field of longevity, and the ability, or the promise, right, the hope that we could somehow live longer through pills. And I think Poe brought it up really well. And he posed it as a question: would you take a pill that will lengthen your life, but very incrementally, tiny, every single day for over 50 years? You got to do it. 60 years, you got to do it, or a pill that you take and it'll do it very quickly? Well, for me, it's kind of a trick question, because the pill that you take every single day, that's tiny effect over time, is called eating healthy, sleeping well, and doing all the things that you should be doing to live a long and healthy life. And then, the corollary is, okay, well, what's the pill that's going to help you in the short run? Well, let's say you have a life-threatening illness like cancer, or cardiovascular disease. That's where modern medicine has been going, and trying to mitigate and eliminate those diseases. And so we end up living longer and longer. And we know that cancer will never be, quote unquote, cured. It can only be treated, because there's infinite causes to cancer. And so, we'll just, as we live longer and longer, we'll get to the thermodynamic ends of what we're talking about. And that's when we're learning. Because right now, we're talking about telomere length. We're talking about all of these things that are still in the realm of actually truly fixing disease. It's disease that gets us, right? It's not literally just falling apart because we can't move anymore. And so longevity as a field, for me right now, still has an identity crisis about what is it. And most longevity companies that are therapeutic, that they're doing some sort of pill, end up being either cancer treatment or metformin or something like that, which is really hard to measure.
I think the fundamental challenge of the longevity field to date has been a reliance on mouse models. Mouse models, mice live 2 years, and they don't live very long. So it's like, you can take a Volkswagen. It's like, I could do all these things to speed up this Volkswagen. And then someone says, okay, now let's put it in the Ferrari. And it's like, it's already living. It's already doing all that. The Ferrari's already doing all that. A human compared to a mouse is like a Volkswagen compared to a Ferrari. Humans live so long. We have fast metabolism when we're young, then our metabolism slows way down and we can live for so long. And we're rare amongst organisms that do it. There are other rodents that live, 10 years or 12 years. I actually would love to see studies on bats.
Yeah,
Bats live. Now, bats do have an extra copy of TP53, and therefore they're going to protect themselves from viruses and cancers and things like that. But bats live 40 to 50 years. And
heart
they're
rate insane.
Heart rate 1,000 beats a minute. So insane metabolism. They should be being torn. Their DNA should be being torn up, but they survive it. If you could make a bat live longer, you'd have a better clue as what makes a human live longer.
Right.
And if you actually look at it, like if we work with, say, human neuronal cells, Sigma Aldrich, you can get a little vial of them for $500. They're actually only like 7 days old. And so all the stuff about senescence, like that is not a neuronal cell that is 90 years old or 60 years old. It's a cell that's about 7 to 2 weeks old, 7 days to 2 weeks old. And so they're not actually challenging in the same way as a model. We tell everybody who applies to us, put it in a dog. Put it in a dog. We'd love to see people learn to use bats, but put it in a dog. Going back to the pill thing, I would say, like, I would be personally very scared of any sort of pill or treatment that worked rapidly on me. And the reason is because of the such proximity between cancer and longevity, and even living longer. Every time your cells divide, it's another pull of the lottery machine.
Mutation in an oncogene.
Right.
No. Mutation in an oncogene. Yes. Did it get repaired? No.
Yeah.
Looks like we have a 5-minute warning here, Poe. So I'm going to ask you then.
Okay.
Where should we be going with what's on the frontier for trans tech and biology? Where is IndieBio going? Where's Mayfield going? Where should we be going?
Well, we're here in the context of happiness and mental health.
Yeah.
I'm a big I'm not. This isn't that variant of perception, but I'm a big believer in inflammation at the periphery, finding its way to the brain over a long time. That the most important thing we can do is reduce inflammation, and that is achievable. That is doable. In the next 20 years, 30 years, to continue to improve on that. And when we say inflammation, it's very important. I'm sure everybody knows this, but we're not talking about like the kind of inflammation you get when your knee is swollen. We're talking about fundamentally free radicals. Every time you breathe, free radicals coming off, spitting down your genome, tearing it apart, as well as cytokines then being delivered throughout your body and creating a lot of signals that lead to a variety of things, including autoimmune disease that starts to tear you apart. And I think that the advancements in autoimmune disease are going to have a massive impact on mental health and on wellness generally.
And here's this isn't variant anymore, but understanding mental health and drug use, what was formerly known as recreational drug use, and using it more like psychedelic medicines, and using it more as therapeutics and guided sessions where you can learn more about yourself. Back in the day, Poe, you and I would call psychonauts.
Yep.
But now, the psychonauts were the first edge of what people are exploring today as true therapy. MAPS and what everyone's doing right now is really important. I think that's the very beginnings, literally the very first inning of a broader exploration through mechanisms of action, understanding how we could heal ourselves, because so much trauma, at the risk of sounding new agey, so much trauma we carry through our life, and it continues to repeat itself through our actions, and it is often very destructive behavior. And one of the chapters in this book talks deeply about that, and it's really about breaking that to stop harming others around you and people that you love, things like that, and really take control over your own life. Because something that I believe very deeply, we're all shaped by the invisible bars of society around us, right? I live in San Francisco, so therefore I think about organic food, of course. If I grew up somewhere else, I wouldn't. Like, it's pretty simple. And so much of our lives are governed that way. How do we take control over those or break free of those invisible bars and truly become us as individuals and have the ability to express ourselves that way? I think that's where a lot of the next wave of research is going to be, and that's all going to happen through the brain.
And I think that psychedelics, which are, I think, awesome here for mental health, are we're going to understand better and better their role in and anti-inflammatory properties, regulation of glial cells, and in addition to sort of the synaptogenesis approach to improve on overall ability to sort of to feel like life is not wearing you down as much. So with that, we'll bring Jeff back on.